Hey, what's going on, guys? Let's do this problem right here. Here this question is asking for Q dot, that is heat transfer rate. And if you look at this picture, we don't have a straight area, right? The area is changing by the distance. Initially we had 10 centimeters square and final area is 20 centimeters square. But heat transfer rate is going to be equal everywhere because this is a linear path. And whenever we have heat transfer in series, it's going to be equal everywhere. So the area is going to change. So we have to write area in a different way right here. So in this kind of problem, what we do is we take area as a linear path, like y is equal to mx plus b. So we express in terms of this. And if you want to express area like this, what we do is if we take area as our y value, that's going to be equal to slope. So slope is going to be the difference of this area. 20 minus 10, that's going to give us 10 centimeters square. That's equivalent to 0.001 meter square, right? And divide by the distance, that is 1 meter. That's going to be our slope times x plus b, that is going to be initial area, that is 10 centimeters square. That's going to be 0.001. So this is going to be our expression for area. Now we have the area, and also the temperature is going to be difference in each distance, because if you have a straight pipe, then temperature is equal as the distance goes along, right? But if you have areas, if the area is difference in each case, as the area goes, as the distance goes, the temperature also going to difference. So we cannot write delta T over L. In this kind of problems, we have to write delta T over, dt over dx. So this is the one we are going to use instead of delta T over L. Now let's write our new equation. We are going to have Q dot, that's equivalent to Ka. Area, instead of area, we plug this value. That's gonna be, so this is actually only copper, right? So we don't need this information. Now let's use this area. This is 0.001x plus 0.001 times, instead of delta T over L, we use dt over dx, because the temperature is it differentiates with the distance, right? So it's gonna be dt over dx. Now our purpose is to find Q dot. But before we find this one, let's arrange the like term in one side. Let's take all the dx in one side, right? X values. So dx over 0.001 x plus 0.001, that is equivalent to k times dt. And also we have Q dot right here. So here we have to do integration. Now let's do the integration. Now let's get rid of this part right here. Okay, so let's do the integration. If I integrate this distance, this is going to be dx over 0.001 x plus 0.001. Now to integrate this one, we have to have a proper term. So let's put 0.001 dx. So if I multiply here by 0.01, I have to divide this one by 0.001. And other side we can, and also the distance is starting from 0 to 1 meter, right? So that's our limits for distance. Now let's integrate this dt also. Here we have k over q dot and integration dt, and that temperature is from 0 to 100 degrees Celsius. And if you integrate this one, that's going to give you 1 over 0.001 ln 0.001 x plus 0.001. and the limits of integration is 0 to 1. And in the other side we are going to have kq. If you integrate dt, that's going to give you t. So we are going to have k over q dot times t, q dot times t. Now let's simplify this one. If you plug 1 for this one, this is going to be 0.01 times 1 plus 0.01, that's going to be ln 0.02. So we are going to have 1 over 0.01 ln 0.002 minus, if you plug 0 for this one, the first value is going to be 0 because times x, that's going to be 0, and this is the only one that's going to remain, that is ln 0.001. That is equivalent to kq times, this limit is 0 to 100, so this is just going to be k over q dot times 100. We can also plug the k value. Thermal conductivity for copper is 385, so this is going to be 385, right? Now let's continue this one right here. So here we are going to have 1 over 0.001. Now when we have ln that is subtracting each other, we can divide. So this is going to be ln 0.002 over 0.001. That is equivalent to, also I can multiply this 0.01 other side. If I multiply this one, 0 from 100 will already cancel, and one of the 0 will cancel with this one. That's going to be 38.5, right? Because this is same as dividing by 1000. So that's going to be multiplying this by this one is the same as dividing by 1000, right? So that's how we got this value. And here we are going to have q dot down right here. Now our purpose is to find q dot. Now if you simplify this one, that's going to give you ln 2, because 0.02 over 0.01 is same as 2 over 1. So this is going to be ln 2. That's going to be equal to 38.5 over q dot. And from this one, you can calculate q dot. Q dot is going to be equal to 38.5 over ln 2. And if you calculate this value, you should get 55.54 watts, and that's going to be the final answer. I hope you guys find this video helpful. See you next time.